Hello and welcome to the AI Research Roundup. I am Alex and today is May 12th, 2025. We are looking at a research paper from Hugging Face's trending list, published just 5 days ago, titled OmniGIRL, a multilingual and multimodal benchmark for GitHub issue resolution. This paper explores using AI to automatically fix software issues. It points out that existing benchmarks, those standardized tests for AI, often fall short. So the authors introduce OmniGIRL, a new benchmark that is multilingual, multi-domain, and also multimodal, meaning it uses diverse information, like both text and images, to test AI on more realistic coding problems. Alright, so to really see why OmniGIRL is a step forward, the authors present this table. It compares OmniGIRL to other existing datasets for what they call GitHub issue resolution. Essentially, the task of AI automatically fixing software problems reported on platforms like GitHub. You can see older benchmarks, like SWE Bench, typically focus on just one programming language, say Python or Java, and importantly, none of them incorporate visual input. But OmniGIRL, well, it supports 4 languages and uniquely includes visual data, making it a more comprehensive test. So how did they actually build this OmniGIRL benchmark? Well, this figure lays out their pipeline. They begin by selecting top programming languages in diverse code repositories. Then, they gather pull requests, which are suggestions for code changes that developers submit for review, specifically focusing on those linked to reported software issues, and that include tests. From these, they construct individual task instances. A really important step is then verifying solutions by actually running code, using what they call fail-to-pass tests. These are tests that are broken before a fix and should work correctly after the fix. Finally, they filter images, keeping only the truly crucial ones. Okay, so after that meticulous data collection, including selecting diverse code repositories and filtering information, this table then details the specific software projects included in OmniGIRL. You can see a list of these repositories, like Python/mypy or Webpack/Webpack, alongside a brief summary of what each project does, and, crucially, a domain tag. These domain tags, such as code quality or web development, really underscore the multi-domain nature of the benchmark, showing it draws from a wide variety of software application areas, making the AI's task more challenging and realistic. Okay, so to further illustrate the kind of rich, multimodal information OmniGIRL incorporates, this next figure shows examples of images found in issue descriptions. You can see screenshots of code, error messages or logs, which are essentially detailed records of software events or errors, and even visual comparisons of unexpected versus expected outputs. These images are often crucial for understanding the problem, and including them really tests an AI's ability to go beyond just text, a key challenge highlighted by the authors when they later evaluate different AI problem-solving strategies. So, with this rich, multimodal benchmark established, this table shows how current LLMs actually perform. We see models like GPT-4o and Claude 3.5 tested using 3 different problem-solving strategies. The key metrics are resolve rate, that is the percentage of issues the AI truly fixed, and apply rate, which is how often suggested code could be applied without errors, even if not correct. Overall, performance is limited. For instance, the best resolve rate achieved is only 8.6% by GPT-4o using a method called Agentless X, underscoring OmniGIRL's difficulty for current AI systems. Building on that general performance overview, this table zooms in on how these models fare on OmniGIRL 5, a specific subset of issues where visual information is absolutely crucial. We see GPT-4o and Claude 3.5 tested with different problem-solving strategies. Oracle retrieval, which is an approach assuming the AI has perfect access to all necessary information. Agentless X and Autocode Rover X, these being more automated frameworks. They also use settings like Image Augmented Text, or IAG text, where textual descriptions of images are provided. Even then, the best resolve rate is a mere 10.5%, underscoring the difficulty with these visual inputs. So it is clear that even with specialized approaches, current LLMs find visual information in software issues incredibly challenging. This really underscores the main point of OmniGIRL. It is a new benchmark, a standardized test, designed to be multilingual, multimodal, meaning it uses different types of data, like text and images, and multi-domain to truly push AI in resolving real-world GitHub issues. The research highlights that models struggle significantly, especially with these multimodal aspects, and also with cross-file issues, which are problems spanning multiple code files. That's all for this AI Research Roundup. Thanks for tuning in.